OK，那接下来在2分钟后即将进行我们金齿鬼的下一场演讲，由 Dr. Carola 所带来的 "It's all about the domain, honey. Experiences from 15 years of domain-driven design." Okay, so you can scan the QR code on the top right, and you can go to Slido and ask some questions. So let's welcome Dr. Carola. Hello.
Good morning, Fong. Good morning. I mean, good morning from Europe. You know, we have morning here.
Yeah, it's afternoon here.
Yeah, perfect. Should I start sharing my slides?
Sure. Okay. So, Karan, can you try sharing your slide?
Yes, sure. Here we go. Can you see them?
Yes, very good.
Perfect.
Okay, you can start your speech. Thank you.
Thank you. Thank you very much. Hi, everybody. In this talk, I will show you how to build systems in a way that makes sense for the business and how domain-driven design can help you to do that. My name is Carola, and on Twitter, you can find me under my handle, Carola Lee. I have studied computer science at the University of Hamburg, and I gained my diploma in 1995. And since then, I have done a lot of programming in C++, in Java, even in Visual Basic and in C#, of course, as well. And I have done a lot of consulting, taking planes to visit my customers. And I work as an architect. And Architektin, this is the German female version of an architect. And in 2008, I handed in my PhD thesis with the title Complexity of Software Architecture. I then turned all the things I found out in my doctor thesis into a business model for my company. We evaluate the complexity of software architectures and check whether they are sustainable and how many technical debt they have. All this is written down in my book, Sustainable Software Architecture, with many examples and pitfalls that one encounters on the way to a good architecture. I have been working since 1999 at my company called WPS Workplace Solutions. We started with 12 coders, and today we are 130 coders in the company. We really love modular software systems with a good architecture, and we have been working with domain-driven design since 2004. We are located in Germany, in the middle of Europe, and we are sitting in Hamburg and in Berlin as well. Berlin is the capital of Germany, as some of you might know. We are building enjoyable business software. This means software that the user really loves to work with. Like this one here, you can see on the slide. This is a software to coordinate the construction works on the roads of different large towns. There are 3 towns in Germany that are using this system today. And one part of this system is a touch table to make it possible that people from different organizations, from towns, from water pipe companies, from telecommunication companies, that they meet and discuss their construction work together. And enjoyable business software from our point of view has a beautiful user interface, but also a good architecture. Since only a system with a good sustainable architecture can as well offer a long life, good user interface and good procedures. If we want to have a sustainable architecture, why do we why do we want that? Well, we want that because we want our software to have a long, useful life, and thus pay off our investment that we did in the beginning. And from my point of view, software will only pay off our investment if we have the lowest possible maintenance cost and extension cost. So if it's easy to change the system, if it's easy to extend the system, then our investment was a good one, and we will have a system that lives for a long time. And this is only possible if the system has a sustainable architecture, if it's easy to understand, easy to change, and easy to extend. This saves time and this saves money if we have an architecture like that. This diagram illustrates our goal visually. We want to be able to keep adding a similar number of features to our system for a long time to come. On the y-axis, you see numbers from 0 to 20. Those are the numbers of features that we can deliver per release. And we want to have a high constant number there. You can see it starts around 16 features per release. And if you follow the green path, then you stay on the same level with the features that you can deliver per release. But complexity and technical debt often prevent us from doing so, and we end up with a sad norm down there. The curve goes down, and we are not able to deliver many features anymore per release, which is really frustrating for the users and as well for the development team, of course. During and after my PhD, we have analyzed a great many systems of different ages, sizes, and programming languages. You can see various programming languages here on the slide. In the middle of the slide, there is a pie chart showing how many systems of which size we have analyzed. So if you look at the light blue, there is 120 in there, so we were able to analyze 120 systems, and the size is annotated on the side. These systems had a size up to 100,000 lines of code, so quite small. 100,000 lines of code, those are systems like apps on smartphones or the first version of a software system. But out there are systems that are much larger. You can see the purple ones, 500,000 lines of code. We have looked at 150 systems of that size. And there are also out there a lot of systems even bigger, 1 million, 5 million, 15 million. So there are a lot of quite huge systems out there. And many of these systems are developed in modern programming languages like Java, C#, and so on. But they frustrate their developers a lot because they have accumulated technical debt and complexity over the years of their construction. And unfortunately, some of them are microservice architectures. The great new architectural style that was supposed to solve all our problems when we were told about it around 2012. It used to be that people would call me and say, Carola, we have a legacy system and we need help. It's getting more and more expensive and slower to maintain. Can you help us break the system into microservices? So this was the past. Today, people call me and they say, Carola, we have a microservice architecture and maintenance is getting more and more expensive and slow. What have we done wrong? Yes, what is wrong? Well, with a lot of microservice architectures, people have made the same mistakes they made with monoliths before. I stole this diagram here from Simon Brown because it explains so well what was forgotten. On the y-axis, you have modularity, and on the x-axis, you have the number of deployment units. So on the left side, the two systems have just one deployment unit, and on the right side, you have various or a larger number of deployment units. And if you follow the y-axis, those two systems on the bottom have low modularity, and the ones up there have high modularity. And what people forgot was that a good architecture is actually about creating independent modules. Therefore, a modular architecture is actually the opposite to a big ball of mud. In a modular architecture, independence of modules is the top priority. So even if you have just one deployment unit, you should have a modular monolith, which is on the left side on the top. If you don't do that, you will end up with a big ball of mud, not modular, and just one number of deployment units. This is the one monolithic big ball of mud down there. No matter if you have a monolith or a great number of deployment units, what is shown on the y-axis, if you don't have independent modules, you have a big ball of mud as well in a distributed system with a lot of deployment units. And that is much worse than a monolithic big ball of mud. If modularity is not your top priority, your system will probably look like this. This diagram on the right side shows a class cycle. This is a strongly connected components. Each square is a class, and these classes are connected with lines. This is where they use each other, and the different colors in the diagram show that they come from 10 different modules. This system was developed 15 years ago. I mean, it is in development since 15 years, and today the whole system has 3 million lines of code, which means that this tangled class cycle that has 500,000 lines of code takes a big part in the system. 30 developers have been working on this system for 15 years. If you change one class in this cycle, you have to check the whole cyclic structure to exclude possible side effects. This greatly slows down maintenance and enhancement. Another example, even bigger, 10 million lines of code developed in Java over the last 20 years. When they started, nobody told them about modularity, monoliths, and microservices. This was in 2000. These ideas did not even exist at that time. And you see the result. What you see there is 90 modules, and they are strongly connected. You see arcs on the left side and on the right side. They all need each other. This is as well a real big ball of mud. And of course, for the team, a whole lot of extra work for maintenance and enhancement. What has happened here? Nobody has reduced or controlled the dependencies in these complex structures. And what can we do to prevent this in our microservice architectures? Well, we do have very old principles at hand to prevent the big ball of mud in our architecture. This is high cohesion and loose coupling. Within a module, the classes or packages should work together to fulfill one responsibility. This responsibility connects them strongly together and creates high cohesion. Other responsibilities should be separated into their own module. And outside of the module, we want loose coupling, which means actually low coupling. One module doesn't need much from another module. A module should be complete from a domain point of view. This is what domain-driven design is talking about as well. From outside of the module, only relevant features should be visible and accessible. Details of the implementation should remain hidden. And this is why we call this information hiding. A good modular architecture that follows these principles would look like this. We see here 3 modules. Each of them should have one responsibility and therefore have high cohesion within. The key point is that we should build this architecture in such a way that we have as little coupling as possible between the modules. But this is only possible if there is an idea of a domain architecture. Domain-driven design has given us the knowledge to create independent modules. One module for the sales context, as you can see here on the slide, and another one for the support context. This is such a wonderful idea, and it works. It creates modules that have high cohesion and low coupling, which means dependency control. But unfortunately, not many systems have a domain architecture. The other day, a client called me and said, Carola, we need help. We are having a microservice architecture. Woohoo, yes, I thought inside of myself. And he continued, we are having a microservice architecture for our platform where customers can sell their second-hand vehicles. And we have 270 microservices. Oh, this is quite a lot, I thought. And what is the problem? Well, if we want to change something in the database, we have to discuss this with all teams. What? What does this mean? Well, we looked at the thing, and each microservice was using a library called model jar. I asked them what this is, and they say, well, that's the interface to the database, you know, the one and only database. When the second microservice was built, they thought that they could just reuse the work of the first team on the domain model. So they took the model jar, enhanced it for their purpose, and ended up with an overall domain model. I have an example for you with a similar problem where we try to find a solution. I will explain the diagram to you in a second, but I will tell you the story before. A company called us to look at their architecture and help them to divide it into microservices. And I asked them, well, what kind of architecture do you have? And normally people tell me we have a layered architecture, but this one was different. They said, our architecture follows use cases. This is a criterion from the domain. And I thought, finally, no layered architecture. This will be exciting. And what you see here on the slide is the architecture that we put on the source code with a tool. This tool is called Sotograph. For each use case, we have created a rectangle and written the name of the use case next to it. As you can see here, mailing, import, export, remove, startup, and so on. The dependencies between the systems parts that are programmed into the source code, as you know, are shown on the right side of the diagram. The green arcs go downwards, so they represent relationships from top to bottom. So some class in the mailing use case is using something from the import-export use case. The red arcs, colors are not important at the moment. The red arcs represent relationships from bottom to top. So the remove use case, there is a class in there that needs something or that calls another class from the import-export. use case. After collecting the use cases, we looked at the dependencies and we thought, well, maybe mailing, import, export, and remove, they could form one microservice because they need each other, of course, and then there is a gap. But if you look downwards, you find something which is quite strange, because down there is a part of the system called model. And you guess it, this is the equivalent of the model jar. I told them, well, this is not a good idea if you want to cut your system into microservices. We have to do something about this. And so we tried to distribute the classes that are in this model jar to the use cases. So we took classes in here and moved them upwards, some to the mailing, some to the import export, where they probably belong because they belong to this part of the system, and they form the basis in there. We started, and I think we stopped when we put some classes into calculation, because then the thing already looked like that. As you can see on the right side, we allocated model classes to the use cases, and all these extra relationships, dependencies appeared. They were all hidden in the model. So you can see now that mailing has as well connections to report and to editing, many new dependencies. They were all hidden. So what we can see here is another big ball of mud. So please, if you are building or having a microservice architecture, try to divide your domain into subdomains with small models. Try to create separate models, because then you will allow independent changes. You will have high cohesion and loose coupling, and your team can work independently, your teams, the different teams for each microservices, because each model and each subdomain should be small enough to be programmed by just one team. Otherwise, your team will feel like the chickens on the right side. These chickens have eaten pieces of bread, but unfortunately, some children have tied those bread pieces together with a rope. And after swallowing them, the chickens are no longer independent, and they might even die together. So let's look at a solution here. This is a banking example, a bank with 3 business areas: account managing, credit business, and security business. These 3 areas use the same classes: account, customer, credit, and security to fulfill their work. So one big model jar for the whole system. If we want to break them down to the bottom of the domain model, we have to have much more specific domain classes. Account and customer are over here in the account managing, and we as well need credit customer and credit account, and security account and security customer. If you follow this as advice, you will have separate models for all your modules, and each team can work freely on their own domain model. Doesn't that sound great? Yes, but how do we get there? Well, we have to change our understanding of software development. In many organizations that I have visited, the responsibilities are clearly distributed. There's the role of the developers, and the role of the architect is understood like this: developer and architect are responsible for technical questions. Their job is to define which programming language is used, which frameworks and infrastructure is applied, which database to use. The domain knowledge is something that the business analysts have to deal with. However, this division of responsibility will not work if we want our software to be structured according to domain-related criteria. To have a domain-related structure, we have to make sure that the software has its roots in the domain and that the software is reflecting a reflection of the domain. Because at the end, the source code only contains the understanding of the developers, not the requirements written down in the backlog by the business analysts. The source code is the written down understanding that programmers have of the domain, nothing else. That's exactly what domain-driven design wants to help us with. The goal of software development is to translate the domain knowledge into software. To understand the domain properly, we have to talk to the domain experts. They have the domain knowledge in their head. But we have to do this in a language they understand. If not, we will suffer from the model monopoly. This is a well-described problem in psychology. If you use a notation that transports your understanding of something to another person, and you use a notation that only you know, you will have a monopoly on the model. A model like this, for example, this is of course, an extreme example, but the underlying message of the model monopoly is, if you show a model to someone in a notation that is new for this person, it is very difficult for the other person to understand this model. The notation you are using for the model is a new language that the user would have to learn to understand and give feedback. This will result in a feedback like, oh yeah, this looks good, quite complicated. I see you thought a lot about it. This is what users say in a case like that. And then you end up with a software system that does not fit the needs of your user. How do we get to communicate with results that our users understand? What should we do? Well, domain-driven design recommends us to explore the domain together with users and developers in workshops. Two techniques have developed in recent years in the domain-driven design environment: event storming and domain storytelling. These are both workshop techniques that facilitate collaborative modeling. For an event storming session, we meet with the user and developers and model the process in the domain with sticky notes on the wall. Each sticky note represents a domain event. All participants are invited to stick notes, which are then discussed and sorted with the whole group afterwards. This way, you get a quick overview of the process without thinking about the software. Today, of course, we are doing event storming remotely on a Miro board. In a session for domain storytelling, we also meet with the users and developers and model the process from the domain with actors who exchange domain objects and concepts. Today, we also do this remotely with an open source tool called Domain Story Modeler. Let's look at this with an example. This is a domain story for a small art house cinema. In this little program cinema, there is the cinema manager and the ticket agent. Once a week in this little cinema is issued a new weekly schedule for the next week. The process starts in the upper left corner over here when the advertising agency sends the plan for the advertising bookings. Once the cinema manager has received this plan, he starts working on the weekly schedule with his super great legacy system, CineSmall. The small yellow flash on the icon of the weekly schedule indicates that the CineSmall software is used here. Next, the cinema manager gets the plan for the possible film shows from the film distributor, and he looks at the nationwide number of visitors. He negotiates with the film distributor which film he can get, and finally, he finalizes the weekly schedule. Our legacy system, CineSmall, then generates auditorium plans, and the ticket agent can start selling tickets for the new scheduled film shows. The customer comes to the cinema and asks for tickets for a certain film show. The ticket agent checks the auditorium plan to see if he can find suitable seats in the auditorium for the desired film show, and he then sells the seats to the customer. This is very domain specific, as you can see. You don't find any technical terms in this domain story. This is because domain-driven design asks us to be aware that the users speak a different language than we do. It's not good if we impose our technical language on them. That would also be a kind of model monopoly in which we use a model that the user does not understand. No, we have to immerse ourselves into the language of the domain experts and learn it. Of course, not everything, but only the part that we want to map in our software, the part in which our software system should support the users. And what happens then in the software? Are we sticking to our technical terms in the software, in the source code? No, we also use the domain-specific terms in the source code. Domain-driven design calls this an ubiquitous language, a language that we use in all communication if we speak, if we write, if we create diagrams, and if we program in our source code. Of course, the domain-specific ubiquitous language is only used in the domain core of the application. In the technical areas, we continue to use our technical programmer language. Sorry. Okay, but now we have a domain application core, and I thought we want to have separate domain models in the architecture with high cohesion and low coupling, right? How do we get that? To achieve this, domain-driven design taught us the strategic design. Our software system supports users in their work in a domain. Domain-driven design tells us that in a domain above a certain size, there should be subdomains that can help us to divide our software into bounded contexts. Each bounded context sets explicit boundaries for individual domain-oriented paths in the software, and as well in the team organization. Each bounded context is handled by exactly one team. We do all this because our goal, you remember, is high cohesion and loose coupling for our bounded contexts. Let's go back to the process in the cinema and see what we can do there. You remember this. If you look closely at this process, you can see there are actually two entries, that is, two triggers that set different parts of the process in motion. This is an important criterion that they could be two subdomains in here. You see the two triggers on the left and on the right. In addition, the two sub-processes are also decoupled in terms of time. The left one is performed once a week, the weekly schedule, and the right one, whenever the customer comes to the cinema. So in large cinemas, there are also departments for these two sub-processes, the cinema management and the ticket sales. The next very important indicator in here is found in the middle. When the left sub-process is over, there is a flow of information in one direction into the other sub-process. The flow of information is the weekly schedule. And then the process continues with a ticket sale. A way back is not possible. This is a very, very strong indicator of a boundary between two bounded contexts, two subdomains. The work in one subdomain is done and the result is passed on to another subdomain. In the second subdomain, work is continued on the result or with the result. Finally, you can use this example to make another point from domain-driven design clear. Domain-driven design assumes that terms in different subdomains can mean different things. And we can also imagine that here for our cinema, the customer looks at a weekly schedule to find out about the planned film shows. This weekly schedule is much less detailed than the weekly schedule that the cinema manager is working on. He notes the cleaning time of the cinema halls and the ice cream sellers and much more. Let's summarize. We can cut the domain into subdomains according to boundaries in the business processes. Good indicators are the information flow, as you have seen, the process rhythms, or the process triggers. We can cut the domain according to different uses of key concepts in the domain, or as well by departments in the organization or groups of experts. So what does that mean for our architecture with the domain core and the technical separated from the domain core? We get a domain core that is divided into domain modules with separate domain models and separate domain and application services. What would a solution in software look like for our cinema if we split it into two bounded contexts according to these rules? In a good solution, we would have two bounded contexts, cinema manager and ticket sales. The bounded context cinema manager would provide a user interface for scheduling the weekly schedule. This user interface works on a service that allows you to schedule movies in theaters, schedule advertising for movies, and much more. The service itself uses the weekly schedule and the auditorium plan to do its work. The bounded context ticket sales would provide a user interface as well, but for the ticket sales. It works on a service itself, and this service uses the weekly schedule, the auditorium plan, and the tickets, of course. To communicate with each other, the two bounded contexts exchange the weekly schedule and the auditorium plan. But this processing between the two bounded contexts is done asynchronously. They don't depend on each other, they are loosely coupled. A bad solution would be to divide the domain according to the entities involved in the process. Here we will need direct coupling. In this solution, in a solution that is bad, we would have a service weekly schedule and a service auditorium plan, one service for each entity. Both entities would be protected by services and their interface, the methods that are necessary to process the respective entities, because the methods are now each assigned to the service for the entity. At least the ticket sale user interface must work synchronously with both services. In addition, there must be another service for the tickets somewhere. Comparing these two solutions, we see loose coupled bounded contexts on the left green side and strongly coupled system parts on the right side. Domain-driven design recommends us the left green side and not to do strongly coupled systems on the right side. If you go the left green way, you have to live with the fact that you have the same entities in different bounded contexts. The weekly schedule is presented in both contexts. You can see that, and the auditorium plan as well. But what is with reuse then? We have all learned in our software engineering courses that we should do dry a principle. Don't repeat yourself, and don't have duplicated code. And luckily enough, domain-driven design speaks about this as well. Imagine you are building a system for 4 different subdomains. In the old times, companies have organized the work like this: a head team, a team for the body, a team for the legs, and a team for the tail. Well, there were a lot of interfaces between these teams. They have to talk a lot to rely on each other to fulfill their jobs. You see all the dependencies, all the errors there. After a while, reuse starts to take place. This is almost inevitable. The body team finds out that there are things that all body teams need, and the leg team puts together the yellow and the blue part, and the tails create reusable systems as well. This is inevitable because what happens is Conway's law. Conway's law says that organizations with which are designing systems are constrained to produce designs which are copies of the communication structures of their organization, which means if a team is working on something, this something gets closer together. And then reuse gets even further because some developers change team and they start to use the framework of the old team. And then we really have a big ball of mud. Domain-driven design says, don't do this. Go for domain excellence, not for reuse. Let teams build their own domain-specific software from UI to database. If we call up our model of our software again, that means no reuse in the domain application source code. Here, each piece of software should be a specific piece of software for its subdomains as specifically as possible. But in the technical part of the system, there we should definitely do reuse, that's for sure, but not in the domain specific part. And finally, I want to show you that it is possible to find out where you stand when it comes to modularization within your system. If you want to know how modular your source code is, whether if it's microservices or monoliths, we can measure this with the modularity maturity index. If the modularity is poor, the system is rated 0 to 4. If the modularity is quite mediocre, we give 4 to 8 as great. And if the modularity is good, the system gets 8 to 10. The x-axis represents just the time. And now I will show you some systems. You can see different cycles here, each of which stands for one system. So these are 22 systems in different programming languages. Some are in the red area, some in the yellow, and some in the green. And on the x-axis is just the time. This was the first system, this is the second, and so on. The system up here was built in Java and has 40 million lines of code. It's very modular, very good. This one, unfortunately, as well is Java with a very bad modularization. This one is Java as well, with some, but not enough modularization to arrive at the green area. This one is C#, but this one up here is C# too. So you can see that the programming language has little influence on the modularity, unfortunately. There's as well PHP, TypeScript, and PLSQL in there. Us, the developers and architects, have to take care of the modularity ourselves. How do we get to this rating? Well, we meet with our clients and we analyze their system for modularity with various tools. You can see here the sonograph, team scale, structure 101, the sotograph, and lattice, all tools that help us to find out about the modularity. There's a quite complex algorithm to calculate the modularity maturity index. Of course, since March 2020, our meetings are virtual, as this one as well. If you want to know more about sustainable software architecture and domain-driven design, contact me via Twitter or email, look at my book, and thank you very much for your attention.
Okay, thanks, Carola, for your vivid and informational speech. I really find your speech very enjoyable. Yeah.
Thank you, Wong. Thank you.
Okay, and especially I love the metaphor of the tree. Your software should root in the domain and your modularity metrics. That's really fun and really inspiring and thoughtful. Yeah. Okay.
Thank you.
Let me see. If you have any questions, please post your question on the Slido, and you can upvote your question so that I can see the question better. Okay. So the first question is, okay, this one. How do you imply this kind of method on a startup company? You have any experience to share?
Oh, yeah. Yeah. This is a perfect question. It's what I understood it rightly. It was about startup, was it? Yeah, Fong, no?
Yeah.
Okay. Yeah. It was about startup, no? Because I can't see it on the screen at the moment. So this is why I asked. Okay.
Okay.
Startup. Startup. I can see the word even within your wonderful language. Yeah. Okay. So in my company, we start, of course, as well, new projects all the time. We create software for our customers. And what I do is I get all my colleagues trained so that they know how to create good architecture. So a startup should as well have well-formed developers that construct the new software, that program, you know. And then one thing that anybody today should do, whatever software you write, you have to do test first, or at least you have to write unit tests, you know, maybe not before, but you have to write them. And if your software is full of unit tests, there's a high percentage of source code tested with unit tests, your architecture will be better. This is an overall experience that I made whenever I looked at any software, because if you want to test something, you start to create separate pieces. You know, you can't have a tangled structure. This is very difficult to test. So please, startups do unit tests, and this will help a lot. And then read books, learn about modularity, and your software will live a long time. So I hope this is a good help for the startup. Test first. Yes. Sometimes you have to create something before you do the test, but test first is the best. Read books, exactly. They all write it down in the chat. Yeah,
totally agree. I think some good practice applies everywhere, no matter in a big company or in the startup. Okay, I think we still have time for maybe 2 questions. So next one, sure. Someone from Anonymous, okay, he or she is very curious about whether we can apply DDD in Agile, how to combine these 2 things to build a more sustainable software. Can you share some insights?
Yes. My company is working Agile since the beginning, and Agile actually fits very well with domain-driven design, because if you do Agile, you have continuous contact with your users. After every iteration, you represent what you've done and you discuss what you can do next. And this is actually what domain-driven design wants. Domain-driven design wants that we have a lot of contact with our users, that we discuss with them so that the developers get better into the domain, understand more about the domain. So these two ideas fit perfectly with each other. There's no problem there. I can see no problem.
Yes, that's a good news. Yeah, I think there are lots of people, because lots of people in Taiwan knows about Agile. So maybe it's a good starting point for them to access DDD. Yeah.
Yes.
Okay.
Absolutely.
I think we still have time for the final question. The final question is, when transforming legacy system to microservice, we find problems like how to break the monolith into parts and keep the data consistency.
Yeah.
Do you have any suggestion about this, about how to do the migration, or any tips?
Yeah, very good question. Yes, it's a big problem, because you have to cut the thing, as I showed you on the slide as well, down to the database, and you have to separate the database into different parts. So you will have one database per microservice. And of course, this is scary in the beginning, because you think, oh my God, I have the customer here. And I mean, you have seen it on my diagram, the customer in the account management, the customer in the credit, and it's always the same person. What does this mean? Well, actually, it's not such a problem, because each bounded context works on a part of the customer that the other one is not working on. And you can transport the data from one database microservice to the other by events, and by what do you say, by distributing the data from one microservice to microservice. And actually, this is something we do in huge companies anyway. We have a lot of systems there, and we always transport the data about the customer from one system to the other. So it's not such a scary thing. Of course, you have to keep them consistent. And that's sometimes it takes time to get all the systems in sync. But you know, with Amazon, Netflix, and all those companies, there is no need to be consistent everywhere in the same moment. You can have some delay. It's not a real problem in general. Yeah.
Okay, thank you. Very insightful. Yeah, and you also raised my bells about your speech, talking about sometimes maybe you should forget about the microservice. Maybe you should consider more about your modularity and multi context. Yeah.
Yes.
Cool.
Absolutely.
Okay, thank you again. Yeah, thank you again very much, and we are very honored to have you here. Yeah, thank you. And okay, so the session ends here. If you have any more questions, or if you want to have a talk with Carola, you can go to the private room with her, and you can have a good talk. So thank you, Carola, again. And the next session will start at 4:30. Yeah. Okay, 4:30. Yeah. So the next speaker will be Lucas. So okay, see you everyone. Goodbye.
Bye bye. Thank you, Wong. Thank you, everyone.
Thank you.